Hey, it's Mike from Arnold Tutoring. Just wanted to go over a quick video on how to solve exponential equations. These are great questions to get on the provincial exam because we know they're going to be there and we know it's really easy to solve them. We just have to identify one thing. Can we make the bases the same or can we not? So exponential equations are when our variable, our x usually, is found in the exponents. So here's two different examples. Again, we're just going to look at the bases and we'll say, can we make these the same? In other words, can these numbers be made up of the same base, or can we not? In the case where we cannot, those are going to be calculator questions. So that's another hint that they'll be on the calculator section of the provincial exam. Let's look at 3 and 7. Those don't share any common base, so whenever we have that, we need to log both sides so that we can bring the exponents down and solve for them. Solve for that x. I'm going to use ln, but you can use log of any base as long as you do the same to both sides. So in one step, I'm going to bring x minus 4 down when I log 3, and bring 2x plus 1 down, 2x plus 1, when I log the right side, ln of 7. Now we multiply out the brackets, get everything with an x on one side, everything without an x on the other side, so that we can factor and cancel and solve for x. Let me show you. So multiply x ln 3 minus 4 ln 3 equals 2x ln 7 plus 1 ln 7. Everything with an x I'm going to bring to the left side. So I've got x ln 3. I'm going to minus this 2x ln 7 over. And then I'm going to bring the 4 ln 3 over on this side. It'll be positive because I'm going to add it. Plus ln 7. Now I've got everything with an x on the left, everything without an x on the right. That way I can factor out my x, divide by whatever's left over, punch the rest in the calculator, and you're done. X, I'll be left with ln 3 minus 2 ln 7 equals, the right side remains unchanged. And I'm just going to divide by this bracket on both sides. So this will cancel and I'm left with x equals 4 ln 3 plus ln 7 over ln 3 minus 2 ln 7. You can punch that right in your calculator and get the final answer to 3 decimal places or whatever they might ask for. Just make sure you put brackets around your numerator and your denominator when you enter it in your calculator. So again, looked at the bases 3 and 7, we can't make those common, so we took the log of both sides in order to be able to bring down our x values onto sort of the ground level using the laws of logarithms, and then multiply it out, everything with an x on one side, factor, divide, and you're done. And those always work the same. Now let's look if we have another exponential equation given to us. I'm going to see, that this is not on the calculator section, most likely, so that's a nice little clue that we're not going to be taking the log of these odd numbers. Secondly, 2 and 16 should sort of jump out at us as we can make those the same base. I'm going to use base 2, so we don't even need to change the left side. It's already on base 2. But 1 over 16, this is the same as 1 over, I'll actually write it up here. 1 over 16 is the same as 1 over 2 to the power of 4 on the bottom. How can we flip that? This becomes 2 to the power of 4, 2 to the power of negative 4 on top, or over 1 if you want. So we flipped it and changed the sign of the exponent, which is perfectly legal. So I'm going to replace 1 over 16 with 2 to the negative 4. It's still to the x plus 5 on the outside. I've just rewritten it as of base 2. Now we can say left side's the same. Our exponent laws say when we have an exponent inside the bracket and one outside the bracket, we can multiply those. So this becomes 2 to the negative 4 times x plus 5. Now I've got 2 to the something equals 2 to the something. And this is the key point. Whenever we've got two bases that we can make them the same, the goal there is to literally have one base to a certain exponent, the same base to a certain exponent, so that we can just drop the bases and say, well, if this is true, the exponents must equal each other. So I'm just going to write that. 3x minus 2 must equal negative 4 times x plus 5, because we're trying to solve for x, and that's it. Now it's a simple equation. Multiply the 4 through, minus 20. Add the 4x over here, and I get 7x equals, I'm going to add the 2 over, so minus 20 plus 2 is minus 18, and x equals negative 18 over 7. So from this point forward, it's just a simple linear equation to solve. So those are the two types of exponential equations that you're going to see on the provincial exam. I hope you found this helpful. Our provincial exam prep seminar is happening on January 20th at the U of M. I think any student, whether they're looking for high 90s on the exam or just to pass, will find it really helpful. We're going to give lots of tips and tricks just like this one. You can register at arnoldtutoring.com. Thanks.